Welcome, everyone, and thank you for joining us today for our closing keynote of Build with Mapbox 2025. Before we get started, I'm going to run through the standard reminders that I'm sure you're all very familiar with now, but in case anyone's joining us for the first time, this session is being recorded. You'll be able to watch the recording on demand in the Zoom event lobby. Also, if you would like to enable captions or automatic translation, that is available for you at the bottom of your Zoom screen. And this keynote, we will have time for Q&A. So if you would like to ask questions to our guests, please submit through the Zoom Q&A feature. That way we can keep track of questions a little bit easier than in the chat. And yeah, that's it. Please go back and discover all of the sessions from the week in the Zoom event lobby or mapbox.com/build. We hope you've had a really enjoyable time with us this week. That's all the logistical notes from me. So with that, let's get started. So this keynote conversation is with two very special guests from WatchDuty. Dave Merritt is the CTO at WatchDuty, and Gabe Schine is a principal engineer with WatchDuty. And joining them in conversation is Joel Groen, a product manager on the Mapbox Maps team. So to begin, let's get to know WatchDuty a little bit and their mission with a brief overview video, and then Joel will get us started.
A 911 dispatch center receives a call about a vegetation fire. Our automated monitoring system hears that 911 dispatch and alerts our team in our internal messaging tool, Slack. All available WatchDuty reporters in that region begin monitoring their radio scanners, wildfire cameras, satellites, and other public sources such as official announcements from law enforcement and fire services. The team vets all available information and waits for on-scene personnel to give an official report on conditions. If there is a threat to life or property, we will notify the affected public via the WatchDuty app. Our reporters follow a strict code of conduct when notifying the public. Reporters will continually monitor the incident and update the public along the way until the fire is extinguished or no longer a threat to life or property. Stay safe from wildfires when seconds count. Download the free WatchDuty app today.
All right, thanks for that. Now, over to you, Joel.
Thank you, Marina. We're really excited to have WatchDuty with us today for this session. It's one of those apps that I know a lot of Mapboxers are really proud to be associated with, and it's really one of those great examples of how our technology supports organization whose mission is kind of directly tied to the greater good. And I saw some examples of others in the chat already. So this will be right in line with that. On a personal note, I have family in Central Oregon. We are all huge WatchDuty users, especially during fire season, and I can check in to see if there is outdoor activities for them or if they are bound by smoke by just checking in on WatchDuty. So I'm really looking forward to this next hour, and we're going to get started by introducing you to our two guests and letting them tell you a little bit about their role at WatchDuty and WatchDuty itself. So Dave and Gabe, take it away.
Thank you for having us. My name is David Merritt. I'm the CTO at WatchDuty. I was one of the founding volunteers and transitioned into a full-time role 2.5 years ago. I lead the engineering efforts and really just try to make sure this critical service is staying up and constantly improving. Gabe?
Hi, my name is Gabe. I'm the principal engineer at WatchDuty. Prior to joining WatchDuty, I had a pretty long history in tech and was also a firefighter starting in 2018. And I experienced a large fire close to my home and got to experience a lot of the problems people were experiencing in terms of the availability of information. So in 2021, I got connected to the WatchDuty team. And it was just an obvious match, and I joined immediately as a volunteer.
Great, thanks, guys. So the WatchDuty app is largely based around the map experience. So, Dave, to get us started, I'm wondering if you would kick us off with a tour of the key features of the app and how it uses the map to convey critical information to your users.
Yeah, happy to. I mean, I think the biggest thing that we do is tell people when there are wildfires near them, and then give them the context and information to make decisions. That's all rooted in the map in geospatial context. You could know that there's a fire near you, but if you don't know where, it's hard to make good decisions. Um, so one of the initial questions we answered for many people is how close is the fire, and where's the wind going? We stay on the facts, but people interpret through the map. Where's the wind? Where's the fire? Where's my house? Is this an immediate risk to me? Um, Again, we believe in giving people actionable information, time to prepare for themselves, time to prepare for their community, and those may be closer to the fire. So we try to let people know with a push notification as soon as there's a fire that we believe is a threat to life or property. It may be that there aren't evacuations for an hour after they get that initial push notification, but now they've had an hour to take a look at the map, to understand what's going on, to kind of collect their things if it looks like a serious situation. Um, and then they can follow along. They can do things like watch the firefighting aircraft. They can see fire perimeters as they're published from authoritative sources. They get updates along with the fire metadata from us, telling a narrative about what's occurring, both from the fire suppression efforts as well as the fire's growth. Um, we're going back to the map thing, going back to the map context. We believe that it's really hard to take in just a wall of text or information without understanding the geospatial context. So a great example of this are evacuation zones. We did a long project. Gabe here spearheaded that to bring in, normalize, and aggregate evacuation zones across disparate data sources, which didn't exist at the time. So, and the aim of that was to show evacuation zones and their statuses to people in a consistent way on the map, so they can see my house is here, the evacuation zone is there, and without that, a lot of it used to be the evacuation zone is north of Main Street and west of Cedar. And some people can take that and project that onto a map in their head, but that's a really small percentage. Even with maps, I think, this is giving people the best possible opportunity to make the best choices about what their family does, what they do, what their community does. We've had great response from this. And we have a user base of 7 million app installations and over 18 million unique users in the past 12 months. And that's been, heavily based on, I think, on how usable and how feature rich our map is.
Awesome. Okay, let's start jumping into the nitty-gritty here and talk about how you've actually built the app. It's clear that WatchDuty balances sharing a ton of information while still needing to keep the UI really intuitive and easy to use for people, especially in high stress environments. So, Gabe, can you talk a little bit about how you all maintain that balance between dense information and usability?
Yeah, I'd be happy to. To be honest, it's a bit of a constant battle, right? One of the things that WatchDuty does very well is it aggregates information that is distributed across a number of sources into one experience. And but if we showed people absolutely everything, the app experience would become kind of difficult to follow. So one thing that so instead, we triage the information, which means we actually eliminate, some of it, and we organize it, and that's true on the map as well as in the app experience and the other content. So from so a couple of considerations here. Geospatially, it's not unusual that a lot of a lot of our additional layers have data at the same time, right? If you have an incident, you might also have a fire warning polygon from the national government telling you this is a high danger area. You'll have a fire perimeter, you'll have evacuation zones, you'll have satellite hotspots, and on and on and on. And these are all kind of geospatially associated for obvious reasons. That is really challenging to show in a way that's easy to understand. And so, from a technical standpoint, we take advantage of Mapbox style language very extensively. It's a very expressive language, which is good and also challenging. But just to rattle off a couple of things that we do, we have iconography that changes its color and expression depending on feature properties. We use a lot of zoom scaling. We think about where we're going to inject polygon layers inside the base map layers. So for example, we always want roads to be above, other stuff because people need to understand how to get into and out of certain areas in an emergency. We change style with zoom and so on and so on. So we really take a lot of advantage of that. And I have a couple of examples here. In this slide, you've got two screenshots of the map at two different zooms. So on the left, you have kind of the countrywide overview. And if you'll notice a couple of things, there are fire incidents that are, kind of evolving and potentially dangerous. And then there are a bunch that have either been completely suppressed or haven't yet sort of hit that threshold of this is a threat to your property or your life, right? So if you're zoomed all the way out, those icons for the not as critical incidents actually get a lot smaller than the others, and we also sort them behind all the other incidents. So if you compare to the picture on the right, the gray icons and those icons with the little crossed out bell in the middle, which probably just looks like a white blob currently, they're larger comparatively on the right as you start to move in. Our reporters are also able to see these camera locations that have recently moved, possibly to pan to look at a smoke column. And that's what the blue dots with the red lines are. But we hide all of the other cameras because it would just be a lot of noise on the map, right? So if you continue to zoom in on the next slide, here, the user started to move in on the left. You can see the other blue dots, the camera locations, and you continue to zoom in, but that fire weather polygon, it's now covering the whole screen. It's not providing information anymore. So we actually just take it out entirely. This is a different context. The user now wants to see the details. And at this point, that's just, it's not added information anymore. So, that the styling controls that we have with Mapbox are, a big part of why we chose to go with Mapbox in the first place. Another small thing that helps a lot is when you're looking at a road, the iconography looks like what people see if they're driving on a road in their area. And that seems small, but for a person who is under stress, being able to get that contextual awareness with less sort of work is really important. the 1,000 paper cuts of stuff people have to work around is what creates a difficult to use app. So we're constantly iterating, on that style and that UI experience. Another thing just to keep in mind, it seems small, but the styling also changes if you're on a different base map. So on the left-hand side, you can see, for example, that the perimeters on the evacuation zones or the stroke outline, it's a little bolder. And that's just to make it more visually apparent where it is. Additionally, the perimeter of the fire has a bit more brightness to it. It kind of pops a bit better. So it's a million tiny details, really. But the Mapbox style editor and style language are really, really powerful tools there.
Wow, great insights. Thank you. Let's go technical a little bit for our developers on the call and just talk about the technical development of WatchDuty and obviously with a focus on the geospatial infrastructure that makes the app work uh, both on the front end and on the back end. So maybe share, and I'll throw this one to both of you, maybe share some of the things that you've learned along the way in your development.
Yeah, I'd be happy to. I think I put a slide in if you could go to it that has the kind of progression over time. Um, so we started out really, really simple, right? We had just a couple of engineers, and our client used a library called Leaflet, and we had raster base maps, and all of our additional content we pulled in with GeoJSON and just put it in the map. Um, that worked fine at first, but we started to run into some performance problems adding additional stuff into the map. We so we started generating our own vector map tiles, and we moved over to MapLibre, and started to serve the tiles with S3. And so that kind of alleviated some of the client-side performance issues. It allowed us to put on like historical perimeters for fires in a performant way. And we continued to use OpenStreetMap's tile data. And when we wanted to take more control over the base map tiles themselves and the styling, that was when we turned to Mapbox. And we actually did a transition to the Mapbox client library. It only took about a week to do. It was quite easy, actually. And so that worked really well for quite a while. But one problem that we kept running into was for data that changes really quickly and that we would like to put, on the map, in as quickly as possible. Static map tiles on S3 weren't really cutting it. So, just an example of two ends of the spectrum, right? For like electrical transmission lines, which don't change very often. We can create static map tiles, put them in the cloud, and a month later compute them again and update them, and that's all great. For evacuation zones, however, we need to be able to respond to a change in the zone's shape or its status. That would be like upgrading from a warning to an order. That needs to go on the map as quickly as possible. Seconds if possible. So this year, early in the year, we added in a Postgres database, and Martin Tile server, which is sort of a pass-through tiles tile API to Postgres, and our caching infrastructure. We went from CloudFront to Fastly, and so with that move, we can theoretically actually change the content on a map in under a second from the time it's changed in the database. So that's what we use to power, our evac zones and a number of other tile sources. So that kind of hybrid serving infrastructure, just the live computed tiles, we hit 100,000 QPS bursts. Our cache hit rate is about 90 to 95%, which is awesome. And so that allows us to serve millions of users a day with pretty minimal cost in terms of our infrastructure. So we try to do what we do really well, but everything else we try to find partners who can do just like do it better. So Dave's going to talk about that a little bit.
Yeah, thank you, Gabe. I mean, looking back at that slide, again brings us back to WatchDuty trying to be very pragmatic. We started with a tiny team. We picked the simplest solution that we needed, and as we saw pain points, we then invested in more complex technology. And I think that same came true with our partnerships. We started to talk to Mapbox when we realized that we had limitations on what we could do. We could have invested more in our internal team and tried to go further with MapLibre, but we realized that that's not our core competency. Luckily, Mapbox was open to a great partnership that's been wonderful since. The migration was really easy. We ran into some of the reasons we moved off of MapLibre were, as Gabe mentioned, the style designer, the expressiveness of the style language, the localized road signs, and the ability to work with Mapbox specifically on some bugs that we were running into that we had kind of ran into a dead end with the open source community. We'd found some other people facing the same problems, and we were in a pretty specific place where we're pushing WebGL pretty hard. I think Gabe might talk to this later, but he just looked and we were rendering 300 independent layers right now in our map with most things turned on. And it's WebGL on a mobile device. We're using Capacitor, so this isn't native. And this sort of specific subset to us meant that we had this bug that you're seeing here affecting a pretty small subset of users, but consistently being reported in. And, a huge aspect of WatchDuty is reliability, consistency, and trust. And it's hard to say that we're doing a good job when there's this huge outstanding issue where you really don't want users to see something like this during an evacuation, during a critical moment. So, working with Mapbox has allowed us to allow them to use their expertise to solve some of this. And we're very happy to say that the two outstanding big bugs that we had with the underlying libraries have both been fixed by Mapbox. So thank you very much. And again, kind of moving pragmatically of, okay, let's partner with someone who can do this stuff very well while we focus on our core competencies of aggregating data, displaying data, reporting on wildfires, things like that.
Okay, thank you. Let's talk a little bit about WatchDuty kind of from the perspective of your relatively small company. You use lots of volunteers, and in many ways, you're volunteer-led. How does that affect your technical design and day-to-day decisions that allow you to keep innovating and experimenting with new features, knowing that you need to be always up and running and available and have high quality data available for your users?
Yeah, it's a good question. It's not easy, but um, process-wise, I'd say the most important thing that we do is decide not to do things. So, as we mentioned, we're still a very small engineering team, and we just don't have a lot of time to do a lot. So we just have to be very selective about the feature work that we do, the infrastructure work that we perform. So, one example of that is our choice of Capacitor, which is it's an app framework that pretty much packages a mobile app, or excuse me, it packages a web page as a mobile app. So if you're launching WatchDuty, you're actually looking at a web view that has a page, uh, running in it. That means that 95% of our client programming work is just web development. So we get a lot of capacity back, if you will, by that choice. However, it's not all great. Capacitor means that we're running a mobile version of Mapbox, or excuse me, the web version of Mapbox, when the performance would be significantly better if we were using the mobile native library. So we're pushing Mapbox pretty hard. As Dave mentioned, 300 plus layers that are rendered on the map, a lot of the time. And that also leads to a number of the bugs, kind of triggering a number of the bugs that he mentioned. But when it comes to picking what to work on, we tend to start really small, get a feature out there and wait to see what people are telling us about how it's working, what needs to change, what to add, et cetera, et cetera. And uh, we send people questionnaires. We do a lot of testing. We have a pretty big beta pool, and we launch every week. So we're able to iterate quickly, and it's pretty unusual, knock on wood, that a bug actually gets to production, which is great. Yeah, do you want to talk about other stuff, Dave?
Yeah, just speaking to the size and composition of the organization, we started as a fully volunteer-driven organization for the first 2 years, known as paid. Um, we're now transitioning to a paid engineering staff and have moved from 2 to 10 in the past 18 months. So we're growing rapidly, but still considering, we're at almost 8 million monthly users. It's a really small team considering the surface area what we're doing. So again, being super pragmatic, um, partnering with Mapbox is big on this. Let's not spend months trying to fix this bug in the open source library. Let's ask a partner to help us with it. I do want to do a shout out to Alexander Shuranov in the Mapbox team for helping with this corrupted base map tiles. Um, we didn't pop champagne, but mentally we did. When we released it and suddenly the user report stopped. That was a very, very good feeling. So we really, really appreciate that from Mapbox and from Alexander. We are always looking for new volunteers and people to partner with us. We take on internal volunteers, and we're also doing a new project where we're aggregating and normalizing geospatial power outage data, the first of its kind in the US, to again provide this consistent, consolidated information. People need to understand if their power is going to be out. It helps them understand if they need to evacuate or they can go back home. And again, providing these things that I kind of assumed already existed in a normalized geospatial format is another thing that we're opening up as an open source repo in the next few weeks. Um, that will be an open source connector library that people can go in, contribute to, and suddenly we'll be processing that and adding it to a normalized data set that we can show to our users.
Nice. We always love impromptu product announcements during build. So thanks for that. Maybe share some more. What else is on the roadmap for watch duty that you might be willing to share with us today?
Yeah, happy to. One big thing we're excited about are localized observation weather data. So, everyone knows their weather app, but that's modeled. Everybody, there are raw weather station. There are weather stations to go to. You can go look at them. I look at them for certain things in my daily activities, but it's not easy to get to. It's not accessible. And one thing we really want to do is allow people to set alerts and thresholds on those. So we'll be pushing things out to allow people to alert on river gauges. There's a system of 10,000 plus river gauges across the United States. And people that live near them know exactly the flood heights that matter to them. Same with AQI. We believe that there should be easier alerting on AQI thresholds and that not everyone has the same threshold for when their behavior may want to change. So we're partnering with Purple Air. We currently show the data in our application, but we're going to update the functionality to allow you to set thresholds and get a push notification if the AQI threshold reaches whatever preset limit is good for you or bad for you. We're also expanding features for firefighters and first responders. We're adding fire progression models, which we're really excited about. Fire progression models are something that's really lived in a more academic setting. And when they were in the fire service and exposed to the fire service, it was within limited groups. And we believe that putting in our application and providing a much wider user base and visibility for this will both improve the models and improve the response from fire service. We're also going to be expanding to the full United States at the end of the year. Right now, we're in 22 states west of the Mississippi. So every state but Alaska by 2026. We're also going to be integrating Earth observation data at some point in 2026. There's all this, again, kind of siloed and locked data that we believe will really help the public. And we strongly believe that that data can be exposed and made publicly and freely available. And last, we're expanding and looking into what does it look like for Watch Duty to help in other natural disasters. We all watched in horror at the Texas flooding and have been looking into seeing what Watch Duty could do in those arenas as well to see, can we provide a similar level of information when there's gaps for the public.
Okay. Thank you both so much for all of that great information. We are going to transition into Q&A. So now is your chance to ask two of the OG Watch Duty people to get the insight of what's really happening inside of Watch Duty. So we've got a bunch that have come in already. I'm going to just start jumping in, and whoever wants to take the question, go ahead. So let's lead off with a question about aircraft positions. So let's see, this one came in from Mark. Watch Duty includes aircraft positions in a very intuitive way. Not knowing what the underlying software stack for Watch Duty is, was there any tips one can use for implementing PNGs or icons like your different helicopters with rotating blades?
I can take this one because I love the helicopters with the rotating blades. Yeah, I could probably talk your ear off about this. This is one of those places where I suspect that the fact that we're in a web browser is actually beneficial to us. Since the aircraft are in fact animated PNGs. And we went with that after iterating a number of times, and this had the best performance. And the reasons for that are that the browser is picking the frame rate that it can, that it can handle, and stops animations for stuff off screen, et cetera, et cetera. I would not recommend with a complex map like ours, trying to do animations in the map style itself, because you have to render the entire layer stack for every frame, and that can just get very expensive, especially when there's 150 aircraft on screen. That would be very difficult to do. So, in this case, it looks like it's like part of the map just because of how responsive the aircraft icons are to uh, panning and stuff like that, but it's actually HTML elements that are overlaid on top. So yeah, in this case, it's the web, rendering stack and standards and all of the optimizations that have been put into that, over the last, you know, number of decades.
Great, thanks. Okay, next question. This is another kind of inside look at WatchDuty. What's been the growth of WatchDuty as an organization as a whole, not necessarily just the technical team, which Dave spoke to earlier, over the past 4 years or so? Can you share more about how the team works behind the scenes?
Yeah. WatchDuty's technical team is just a tiny, tiny chunk of what WatchDuty does, and really is there in support of the reporter operations. What we have a huge team. I think we have 70 reporters at this point. We started with just a handful, and another probably 200 contributors and volunteers that are behind the scenes collecting information, helping out, prepping reports, and it really is a big team effort. People are collaborating in Slack. Everyone who's reporting in WatchDuty that's sending out a push notification about a new fire or sending out updates about fires um, has been trained, has signed a code of conduct, has been interviewed. So it's kind of the opposite of crowdsourced. We have a group of expert people that are all working together to provide this information. And we talk about data sources and automation and all this stuff, but in the reality, a lot of what's happening in the most critical moments are people listening to radios and synthesizing that information and then reporting it out to the public. So we try to provide the best possible platform at a technical level for those people to get the information to people clearly and also provide uptime. And that's really the main size of the organization is the reporting and operations side. So I think a lot of people don't see what's behind the scenes, and it's a ton of work. It's a lot of people staying up late at night. It's a lot of people doing long hours, and people that are really committed to their communities, trying to provide information to keep people safe.
Nice. All right. As a product manager, I love this next question. In full disclosure, I'm not the one who asked it, but I can't wait for the answer. So, do you get a lot of conflicting feedback from your massive user base? And if so, how do you kind of decide which of those, if you have conflicting feedback, which one is going to make it into the app?
Yeah, we get a lot of support emails. Not as many as you think with millions of users, but a lot of people have good ideas. A lot of people have other ideas, and I think it's our job to synthesize all that. And I think the challenging part for us now is that we have such a wide user base. We have people that are incredibly tech. We have people that are we have a particularly tech non-savvy user base. It skews older, it skews more rural, but we also have people that are using this in their jobs. We have fire professionals. How do we manage the complexity of information that a power user wants with the simplicity of use that the average user or a person that just got sent a text message from a friend saying, download this app, it'll give you the information about evacuations. So there's always a tension there between those things. We also have a lot of users internally that use WatchDuty because last year we had a couple of reporters that evacuated while they were reporting on a different fire because a fire was near their home. So we use the product ourselves, we dog food it, and I think we listen to all of the different stakeholders and just do our best. Again, the other piece is we iterate on it a lot. We don't get it right the first time. I think we've probably made hundreds of releases to the mobile applications over the past 4 years. And that all gets us to a place where we are now. I look back at the first iteration and it's kind of ugly. We had a long way to go, and we slowly, incrementally made it there through fits and starts.
Nice. I would say most great products follow that arc. So you're on the right path. Okay,
Thank you.
Damien wants to know about 3D maps. Does the amount of layers affect your ability to offer a 3D option so that you can visualize all or parts of the map in 3D? He mentions like seeing a fire zone ending on a ridge line, and how does that impact from a topographical top-down perspective?
Yeah, it's a good question. I think the answer would be yes, it does affect or I should say it's one variable that we consider when we're looking at it. And I think the main reason for that, I'm not sure if it actually has a performance implication. That's not something that we've profiled yet. But from a product standpoint, every layer that works well in 2D might not work well when applied in this way. For example, the aircraft, right? It's not going to look good if you have a flat 2D PNG floating over, uh, you know, uh, a map. Um, and the wildfire cameras, they work really, really well in 2D, but once you're looking at them from the side, the iconography is going to have to change. You might want to use a model, and so on and so on. It, so it's a big product effort. That doesn't mean we'd love to see it, but it's a lot of engineering work and design work. I hope that answers your question, Damien. That's what you were looking for.
Yeah, and it's a great lead into the next question because it is about the inherent tension between design and engineering. So there's a question if you could speak a little bit more about how you develop complex maps and keep both the design and engineering forces working well together instead of against each other,
Yeah.
uh, and just how those get implemented inside your app.
Yeah, I'd be happy to talk about that. So the progression tends to look like this. We have our designers create a mock-up in Figma, and then progress from there into Mapbox Studio, where they will get, most of the way there to the style that we want, and pass that off to the engineering team who will actually integrate it into the app and sort of fine tune and iterate with the product team until everybody's happy. We luckily work really well together, so we don't tend to work against each other. But that's your typical progression. And
Just to add,
yeah, go ahead.
I was just going to add on to that. I think the thing that we love the style, Mapbox style tool, but what we can't see until we're in development are these zoom level interfacing, the 9 other layers we have in our app. What does it look like with 2 different base maps? What does it look like with 3 other animations turned on next to it? And those little tweaks are something that we try to just sit down and do together, because it really does. You need to have it in your hands. Sometimes you need to see it on mobile. One thing I don't think we touched on is that 90% of our traffic is mobile. We have a website, we have 2 apps, but 90% of the traffic is coming in from mobile, and mobile maps are hard. It's hard to provide the right level of information, and that's where a lot of, I think, that tweaking comes in, is in the smaller format.
Yeah. Yeah, absolutely. Yeah, that's a place where also the iteration time uh of web development is really, really, really tight. So we can create a tweak to the style and then see that, seconds later in the web browser. And that's really nice to have as well.
Nice. Okay, data question is next. Can you share more about how you use remote sensing data? Are you exploring that for automatic fire detection, as an example?
Yeah, so it's a growing field. There are more and more satellites passing more and more often, and we view ourselves as a partner to all of those. So I don't think WatchDuty is going to launch any satellites soon. But we do, for instance, have MODIS and VIRUS data on the map. You know, it's also very, very important to us that we post verified information about fires. And that's where we always have a human in the loop. So we have a ton of automation about potential remote sensing, fire starts that come in. But again, a person then goes verifies, do we have a camera nearby? Do we have heat detections nearby? Do we have a 911 call nearby? And those are the steps that take us from pure remote sensing to verified data that we want to push out to the public and that people have learned to trust. So we're really excited for what's coming with more and more satellites being pushed out. The Earth Alliance, I mean Earth something, Gabe, Earth something. Anyways, a lot of fire satellites getting put up in the air, and I think if the promises deliver, we will have really great satellite detection on heat detections, but that gets us just to the beginning of the process for us.
That's a great answer.
Nice. Okay. I think we have a really, really appropriate last question for the two of you, and that is, if I want to get involved with WatchDuty as a volunteer in whatever role that might be, what would be the best first step for me to take?
Yeah, so I would suggest visiting our website. So this is www.watchduty.org, not app.watchduty.org, and hit the join button. Oh no, sorry, should have looked at this ahead of time. About and volunteer. I'll post the link in chat, and there's a place to volunteer for engineering as well as other potential positions. We have a growing organization with not enough people in every role. So, if you find this something that's compelling for yourself, we'd love to talk and see if it's a good fit for a volunteer role.
Fantastic. Gabe, Dave, thank you so much for your time today. I think this is a great way for us to close out Build 2025 and really appreciate all the insight on WatchDuty and the way that you manage a really complex environment and give all of us, myself included, a really useful app when we need it.
Thank you for having us.
Yeah, thanks a lot.
Thank you so much, Joel. Thank you to our speakers, Dave and Gabe. This concludes the live content of Build with Mapbox 2025. All the session recordings are available to watch for the coming weeks. So please do go back, rewatch those, share them, enjoy. A big thank you to everyone who tuned in live, both to this closing keynote and sessions throughout the week. And even special thank you to all of our speakers and the session producers who have worked tirelessly behind the scenes to make this year's event possible. All attendees will receive an email with a feedback survey link. We would love to receive your feedback about what you'd like to see next year at Build and in other Mapbox events and content. So with that, I'll say thank you to everyone and see you next year.